So to demonstrate the material from the last video, I'd like to consider the following example problem. I would like to estimate the slope of the tangent line to f of x equals x squared at the point x equals 2. So first and foremost, I certainly hope everybody has a decent idea of what the graph of f of x equals x squared looks like. It's known as the squaring function, and it is represented by a parabola opening in the upward direction. So even if you don't have an exact picture of it, you can kind of eyeball it like so. So the idea is, we were given an x value. That x value is x equals 2. I can turn it into a point by saying, let's plug x equals 2 into the actual function. So f of 2 would be equal to 2 squared. And my calculator lets me know that when you square 2, you get 4. Now, we were not given a second point on this parabola, so what we're going to do is create our own second point on the parabola. I would like to leave this point as a variable. So the variable that I'm going to use for it is simply going to be x, because that's an x coordinate. The corresponding y coordinate would be whatever that value is squared. So this is how we're going to create a second point. So what we'll do is set up the slope formula for the ordered pair 2, 4, and for the ordered pair x comma x squared. So this will be the slope of a secant line. We'll do y2 minus y1 over x2 minus x1. So it'll be x squared minus 4 over x minus 2. And hopefully it is very obvious that there is a domain issue here. We can't let the second point be exactly equal to the first point, or else we'll, once again, only have one point. Plus, if I were to allow x to be equal to that value, that would force the denominator to be 0. First commandment of mathematics is, thou shalt not divide by 0, so let's not break any commandments today. Next, we are going to select several values of x. Select values of x close to x equals 2, close to x equals 2, and plug them in. Now, close to is, of course, a relative term. What's close to 2? Are we talking about values like 1 and 3, or are we talking about values like 2.5 and 1.5, or are we talking about values like 2.001 and 1.999? Fact of the matter is, everything is relative. Now, there is nothing wrong with selecting lots of these values to get more and more information. Now, to start off kind of far away, what I'm going to do is say, we'll start with values of x that are greater than 2. We'll try out 3, we'll try out 2.5, we'll do 2.1, 2.01, and 2.001, and see if we can come up with something. Now, I do want to show you how to use your calculator to make this process a little bit easier. So, as I mentioned in the last video, if you have a graphing calculator, now is a great time to make sure that you have it handy. If you need to pause the video and come back in just a moment, please feel free to do so. So let me introduce you to some of the features of the graphing calculator, especially those that are super helpful in this situation. I would like to plug multiple values of x into this expression over and over and over. What I'm going to do is graph this expression in the y equals menu, and then show you how you can use the table feature. So up in the y equals menu, if there's already something in there, go ahead and clear it out of there. Now, when you're inputting a rational expression like this into the calculator, the entire numerator needs parentheses, and the entire denominator needs parentheses as well. So when all is said and done, your expression should be inside parentheses, x squared minus 4, close parentheses, divided by new parentheses, x minus 2. Now, the following thing is something that you're only going to have to do one time, and then the calculator will automatically default to that. Second followed by window enters the table setting menu. Make sure that your independent variable has been set to ask. That should be highlighted. If it's not highlighted and it looks like this, go ahead and put your cursor directly on top of ask for independent variable and press the enter key. What that allows you to do, or what the calculator will now do, is ask you to provide it values that you'd like to plug into this expression. Now that takes place in the table menu. Table menu is accessed by pressing second, followed by graph. You're now in the table menu. You can input whatever value of x you want, and it'll tell you the corresponding value of this expression that you plugged into the graphing calculator. So we'll start with x equals 3, and press enter. We get that corresponding slope would be 5. Then, at the next line, we'll do 2.5. We get corresponding slope 4.5. For 2.1, we get 4.1. For 2.01, we get 4.01. And for 2.001, we get 4.001. A lot of what makes an effective mathematician, or student of mathematics for that matter, is the ability to recognize patterns. And I'm hoping that there is enough evidence here of some sort of pattern. Just in case there's not enough evidence of it, though, I'd like to extend the table so that we're using not only values of x that are greater than 2, but also values that are less than 2. So we'll use values like 1, 1.5, 1.9, 1.99, and 1.999. You'll notice that I did these in the reverse order as what we did up here, so that we can kind of focus in on what's going to happen with x equals as close to 2 as possible. So if you have room in your table, go ahead and input all of these values, and we'll get the corresponding values of the slope. Looks like I just barely have enough room. So a big important thing to point out as you're copying these into the table is that we are trying to draw a conclusion about this value of x right here, right in between 2.001 and 1.999. So using your intuition or spidey sense, whatever you have handy, what do you predict the slope of the tangent line would be? What is the slope getting really, really close to as x gets really, really close to 2? Now, again, obviously we can't plug in x equals 2 because it's a domain issue, but hopefully there's enough evidence here to convince you that the slope of that tangent line would be equal to 4. Now, if you wanted to sort of convince yourself further of the result, an additional piece of information that you could do is find the equation of the tangent line. Now, for the equation of the tangent line, we have a slope that we were able to surmise, and we have an ordered pair from earlier. What I'm going to do is do the laziest possible way to do this. If you have a point and a slope, plug them into point-slope form. This will be y minus 4 is equal to 4 times the quantity x minus 2. In order to graph this in the graphing calculator, we need it in the form y equals. I'm not even going to bother distributing. I'm just going to put it in exactly like this to the graphing calculator. So let me demonstrate how to do that on the graphing calculator. So back up in that y equals menu, go ahead and clear out what we just worked with because we're going to be graphing some other stuff now. I would like to graph the original function, which was y equals x squared, and I'd like to graph our tangent line as well. What I should see is that at x equals 2, or more specifically at the point 2, 4, I should see that this line is now tangent. It will touch the graph without passing through it. Now to make sure that we have a good viewing window, go to Zoom, select option 6, which is your standard zoom, which allows you to see from x equals -10 to +10, and y goes from -10 to +10. Should be a good viewing window. Now what should happen is that right at the point 2, 4, this line should come in and touch the curve without actually crossing it. If you wanted to convince yourself even further, you can alter your window manually. We want to look at 2, 4, so let's go from 1 to 3 in the x direction. Let's go from 3 to 5 in the y direction. This will allow us to zoom in a little bit. There's the parabola, and here comes the tangent line. Looks like it touches, but it does not cross right in the middle of the graphing calculator. Now, right now, all that we're doing is convincing ourselves of what a slope of a tangent line should be. In upcoming sections, we're going to be a little more precise about exactly what we're doing to come up with a better method of this than, grab your calculator and toss in a bunch of values. So this is the least sophisticated way to do it, and we are just going to get more and more sophisticated.